All right, time's come for us to talk about what we're building. So what I'm going to do is I'm going to grab the blue pen and I'm going to draw something to represent our layer 3 transport. So yeah, it's a cloud. So predominantly in this is going to be where we are going to have whatever IP support we have in the transport environment. So that's going to be my IP transport. Now remember, we have resources located in separate sites. So over here I have a resource, and that resource is going to want to connect to another resource. Now the way we're playing this is going to be leaf 101 and this is going to be leaf 102, and the assumption here is that our spines are going to be situated somewhere in this transport infrastructure, and we're going to leverage those resources in order to be able to achieve equal cost multipathing. Now the goal here is actually pretty straightforward. What we want to do is between these sites, what we want to do is we want to implement a solution that's going to achieve layer 2 adjacency. We're going to refer to this as our layer 2 VNI infrastructure. So it's a tunnel. It's no different than any other tunnel that we've been implementing. It is going to be a tunnel traversing our IP environment in order to be able to allow us to be able to achieve layer 2 adjacency between these two sites. That's all this is. Now, when we look at what happens here, the thing that we have to understand is there's a number of constructs. So remember, we said that a device, so let's say I have a switch right here, and let's say that device is responsible for doing our encapsulation. We said that I'm going to receive information coming in from, say for instance, a classic Ethernet, and what I'm ultimately going to want to do is I'm going to want to send that information out towards my spines in the form of a VXLAN packet. And this entire process requires me to take my original payload, and then what I'm going to end up doing is I'm going to take that original payload and I'm going to re-encapsulate that payload inside of a VXLAN header and send it on its merry way. But the problem is that encapsulation process has to take place somewhere. And when we look at this, what ends up happening is that this device handles the encapsulation, and we've already said from a theoretical perspective that encapsulation will always be handled by the VTEP. But inside of Cisco, we don't have a VTEP interface. We have what is referred to as a logical interface called a Network Virtual Edge interface. In our case, we're going to be building Network Virtual Edge 1. Now, this logical interface will be providing the services of the VTEP, and again, like I said, it's going to be responsible for encapsulating, but it needs to know how to encapsulate. So when we start looking at this, there's going to be three pieces to this equation. We have the NVE. So we have the Network Virtual Edge interface, and that Network Virtual Edge interface is going to allow me to be able to create my layer 2 VNI. Now, the layer 2 VNI is going to be encapsulated using a header that we're going to use in the purposes of our lab. It's going to be 10100. I do this a lot of times. The last three digits are the VLAN, and this basically just tells me that it's going to be the VXLAN config. So let me go ahead and make this a little bit neater. So the NVE, the Network Virtual Edge interface, has to somehow be associated to the VNI. Now the VNI also has to be associated to the VLAN that I'm going to do encapsulation for. So VLAN 100 exists as a construct inside of my device, because I need to receive information. When I see that information is going to be in VLAN 100, somehow what I need to do is I need to associate it to the layer 2 VNI that I actually assigned to that resource. And the other thing is that since we're using flood and learn, what we're going to do is we're going to want to also have this VNI share its configuration using a multicast group. So we'll have, say for instance, an MCAST group here, and I'll use 23999 as the address that I'm going to be using, and this also has to be associated to the VNI. Now, the way this is going to work is that we actually take this information, associate all of these processes on this side, we encapsulate it and send it across this layer 2 VNI where it arrives on 102, and then 102 is going to be responsible for de-encapsulating it, interpreting it, taking the layer 2 VNI and assigning it to the proper VLAN so that it can be flooded to the other destination. And as we start looking at this, it all really makes sense, because what we do on one side of the equation, we will do on the other side of the equation. And this is the way that we create functional, operable layer 2 VNI configurations using flood and learn architecture. We needed to have the rendezvous points. I'll go ahead and draw in my RPs. Remember, these are Anycast RPs that were running on our spines. They have to process this multicast address. So they are going to be responsible for providing the reachability information using a root-based tree in the configuration that's going to allow us to be able to terminate everything on one of these respective rendezvous points. Now, right now, I don't want to dive deeply into the operation of these RPs. The time will come when we actually have a functioning configuration, and that's going to require us to create the NVEs. And we're going to create the NVE interfaces, NVE1, on both sides on leaf 101 and leaf 102. And then what we're going to do is we're going to entertain how we do this. So I'm going to create the NVE. I'm going to have to associate the NVE to the VNI. And then I'm going to have, for that VNI, a multicast address that's going to provide reachability for that configuration. Then what I'm going to do is I'm going to have to bind my VLAN to my VNI, or actually, a better way to say it probably for memory purposes, well, I will have to go to my VLAN and associate it with the VNI that I want it to provide services for. Now, this is going to require the activation of two services. We're going to have to enable feature NV overlay on these devices, and we're also going to have to activate feature VN segment based. So this is going to be the idea of the VNI will be assigned to a segment, and for the purposes of that explanation, our segment is going to be the VLAN. So let's go ahead and make this work in the next portion of our walkthrough, and then ultimately what I want to be able to do is I want to be able to fire up those hosts, and I want to be able to ping across this IP infrastructure that we just built using this Layer 2 VNI VXLAN tunnel. I'm Terry Vincent, and I'll see you guys in the next video.